All right, and problem number 17 on 8.5, we have this equation and they want us to solve it. One of the ways you kind of know they wanted you to solve it, you see this 0 right here? If they were just giving you the equation, they might have called it p of x or f of x or put a y there. But when you have all the terms on one side and a 0 on the other, what you're doing is you're setting your y equal to 0. You're setting the equation equal to 0 to solve it. Okay, so just thought I would throw that in there because that used to confuse me when I was in school. Okay, now if they want me to solve it, that means I need to find all the factors and set the factors equal to 0. Well, when you take a factor and set it equal to 0, what you're getting is one of these roots here. So what this tells me is, how would I get a minus 3? I would have had a x plus 3 equals 0, right? And then they would have subtracted negative 3 from each side to end up with negative 3. That means that one of my factors was x plus 3. Now, when I'm going to do synthetic division to try to reduce this to a point where I can solve it. There is another way to solve this. You could factor by group this one, but you know what? They asked us to do it this way, and that's what we're practicing in this section. So since I know one of the roots of negative 3 is negative 3, what I can do is take that root. Remember, we never divide by the factor itself. We always divide by the root. The only time we divide by a number, they give us, well, never mind, let me not say that. All right, so let me put my coefficients here. I notice that nothing's missing. There's a cube. I don't know why I wrote over that. There's a square. There's an x to the 1, and there's my constant. So my coefficients is that invisible 1, and then a 3, and then a negative 3, and then a negative 9. So I'm going to go fast on this one just to show you how fast you can go. Drop your 1. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. 0 times negative 3 is 0. Negative 3 plus 0 is negative 3. Negative 3 times negative 3 is a positive 9. And negative 9 plus 9 is 0. Now, because this was a root, the factor x plus 3 actually divided in evenly. They told me that ahead of time, and they actually gave me that number. I knew this was going to be 0 because it went in evenly. Now, what I have left is this. I have x squared plus 0x, so I won't write it down, minus 3. Okay? So that's what's left. That if I were to factor this number up here, I know that one factor is x plus 3. I mean, I could actually rewrite this as x plus 3 times x squared plus 3. That's equal to that original equation up there at this point. Now, I could do synthetic division again. I could do the quadratic formula. I could try factoring. But you know what? This equation, if I set it equal to 0, because I'm still trying to solve it, I've just gotten rid of one of the factors out of it and broke it down a little bit. Wouldn't this would be the easiest to solve just by taking square roots? See, if I added 3 to both sides, I would have x squared minus 3. X squared equal 3. The 3's would cancel out on the left side. And then I could square root both sides and get x equal plus or minus square root of 3. So what are the roots of this? If I completely solve it, that means tell all the roots, okay? Now they gave me one. The roots are, I'm just going to put the roots are, and I'm going to list them in the brackets. They gave me negative 3, and we still want to list it because it is a root. It is a solution. Remember, roots are solutions. They're your x-intercepts. They're called zeros, okay? And the other ones are plus and minus square root of 3 because that completely solved it right there. So you sometimes use synthetic division to break it down a little bit, and then you always got to remember that you still got some other options to use like this. We took square roots, and again, as I mentioned, you could see if something factored. You could use the quadratic formula. You might want to factor by grouping. You might want to, what else? Maybe I mentioned them all. But anyway, you always are trying to keep in mind that you've got a bunch of tools to use, and you want to be smart about what you pick. I wouldn't want to do synthetic division once I got down to this point right here. I wouldn't want to use synthetic division on it because, you know, what are you going to pick? There's a way to figure it out, but, you know, in this case, it didn't work. It would be hard to get that to work anyway. So sometimes you need to switch over to another method after you break it down to a certain point. All right, I wanted to look at another one on here. It's going to be on your test. That's why I'm making sure that we look at a lot of them. Let's look at number, I assigned 21 and 23. Let's look at 23. They give us, in 23, they said find a polynomial equation with integral coefficients that has the given number as root. given number as roots. Sorry, I can't talk this morning. It is early. Okay, so they give us 0, minus 1, 2, and minus 3. Okay, now what this means is they're giving me the solutions. They're giving me the roots. Those are solutions. So how would I get 0 as a solution? X plus what would be 0? It would just be x, wouldn't it? So one of my factors, or one of my factors is going to be x, okay? I'm going to write them all down here. Now, how would I get minus 1? It's always the opposite. It's the same number with the opposite sign. Wouldn't x plus 1 equal 0 if I subtracted 1 from each side, give me x equal negative 1? So one of my roots, one of my factors that gives me that root of negative 1 would be x plus 1. Okay, so if the same idea holds for 2, it would be not x plus 2. It is a positive 2 is the root, but what factor would give me a 2? X minus 2. It's the same number with the opposite sign. And then for a minus 3, it would be x plus 3, because if you set each one of those equal to 0, that would give, and solved, it would give you these numbers that are listed up here. Now, on a test, I would be fine with you listing this way. In this book, that what they do is they make you multiply it out. So I'm going to do that very quickly because it's a long process, and that's what you're expected to do on 21 and 23. Okay. So first thing I'm going to do, I'm just going to pick a couple to multiply at a time. I can only do 2 at a time. I don't know about you, but I'm going to do those 2 at the end first. I'm going to write down my x, and I'm going to write down my x plus 1 that's already there, and now I'm going to go ahead and multiply this out. That would be x squared. And then x times 3 would be 3x, but negative 2 times x would be minus 2x. So 3x minus 2x would be a 1x. And then negative 2 times 3 would be negative 6. All I'm doing is distributing. I'm just doing some of it in my head. If you need to do it all out on paper slower, you can do that. I'm just going to start cutting some of those steps out because we need to move to the point where we are working a little faster. Now what I'm going to do next is, let me multiply the x times both these two together. X times x plus 1 would be x squared plus x, okay? And now I need to multiply that by that, what I got above. So I just multiplied 2 at a time first. And now I got to multiply this out. Okay, so we're distributing. X squared times x squared is x to the 4th. X squared times x is x cubed. X squared times negative 6 is negative 6x squared. Okay, now x times x squared is x cubed. X times x is x squared, and x times negative 6 is negative 6x. So now we're just going to put together combined like terms. I've got, let's see, the biggest exponent I see here is a 4. So I'm going to write my x to the 4 down. Now, next thing down would be an x cubed, and we've got 1x cubed here and another 1x cubed here. That would be 2x cubed. So we've got those taken care of. The next exponent down would be squares. I've got minus 6x squared plus 1x squared would be minus 5x squared. And then the only thing that's left is down here, this minus 6x. And so this would be, if this equation right here would have those roots. Now, you could multiply through by any constant you wanted to and give that as an answer. But this is the simplest answer you could get right here. So usually that's what we write, though anything that you multiplied through by another constant would be the same thing.